Hello friends, welcome to my channel. Let's have a look at problem 508, most frequent subtree sum. In this video, we're going to share a solution based on recursion. So actually this problem can be solved by a number of ways. Here, due to the fact that the binary tree is a recursive abstract data type, so here we're going to use recursion, which we feel is very natural. So first I'll read through the statement and then we share the idea and finally we explain the code. First, the statement. Given the root of a binary tree, return the most frequent subtree sum. If there is a tie, return all the values with the highest frequency in any order. So the subtree sum of a node is defined as the sum of all the node values formed by the subtree rooted at that node. So here it emphasizes that it's including the node itself. So here let's look at the two examples given. So in example 1, so if we look at the root 5, so this tree actually has a sum 5 plus 2 minus 3, that is 7 minus 3, that is 4, right? 4 appears once. So we look at the two leaf nodes. So 2 appears once and negative 3 appears once. So the highest frequency is 1. So the output is 2, negative 3, and 4. And in example 2, so we have this tree. So it contains 3 nodes. So if we consider the subtrees, there are 3 trees together. In total, we need to consider. So if we look at the whole tree, so the sum is 2. So 2 appears once. And then if we look at the leaf node, 2. So this tree sum appears again. So 2 appears twice. So negative 5 appears once. So here the maximum frequency is 2. So we return the corresponding sum, that is 2. So this is the second example. So before we look at the idea, let's also look at the constraints or additional assumptions. First, the number of nodes in the tree is in the range given by the closed interval, with the two ends being 1 and 10 to the power 4. So the first end said that this tree is not null in total, and the second number tells us the upper bound of the problem size. Secondly, the node value is in a range between negative 10 to the power 5 to positive 10 to the power 5. So this in particular tells us that the node value can be negative, right? So with that said, we are ready to share the idea. So here actually we want to do it in a very effective way. So the idea is that we initialize a dictionary. I will call this dictionary cache to store the subtree sum and their frequencies. So here is a pair s and frequency, where s is the subtree sum and frequency is the frequency of that sum. So to actually get the sum and the frequencies, so we could use a hyperfunction. I'm going to call this function worker to do this update. So our function will be recursive and essentially traversal. So the recursion relation is actually very intuitive. So let's call f. So given the root of a tree, so this is the subtree sum of the tree represented by the root. Then in general, so this sum actually can be easily obtained. So we can consider the root value and then consider the left subtree sum and then consider the right subtree sum. Then we add them together. So this gives us the recursion relation. So that's it. So with that said, let's look at the code. So first, as we mentioned, we're going to initialize a cache. So this is a dictionary. And then we're going to write a hyperfunction. So that's called write hyperfunction. So this function, I'm going to call it worker as I specified above. So here, so worker, so it will accept a node. So let's write the root just for a argument name. And then the worker will return the sum of the tree represented by the root, right? So if this is our goal, so then first let's treat a stop condition or base case. If not root, so in this case we're going to return 0 because we have no node at all. So it's also going to be used as a stop condition, right? So next we're going to consider the left subtree sum and the right subtree sum. So that is worker root left, so worker root right. So as we have already considered the base case, right? If we do not have root left or root right, so the corresponding L and R are zeros respectively, right? So this is the one. So what's the sum here? So S will be the root value plus L plus R, right? Then we are going to update the cache, so the cache of this sum. So overall, we want to increment its frequency by 1. However, this S might be not in the cache yet, so we're going to use this cache, so get. So we want to get the frequency for this sum. If the frequency is not in the dictionary, we are going to set the frequency default being 0, and then we increment by 1. So this way we return S. So this actually finishes our hyperfunction. So if we call the work function, because the cache is a dictionary which is mutable, then we will automatically update the cache. So this way we get all the required information. Then we just need to find the highest or maximal frequency in cache and get the corresponding keys or the tree sums. So this is the first step. The second step is function call, right? So we're going to call this function, right? So we're going to call this worker root. So it's going to have some return, but we don't care about the return. So let's use a dummy thing. So let's see worker. So we are going to pass it to root. Then we get the cache updated. So next we are going to prepare the return. So this is also very routine. First we are going to get the maximal frequency, right? So this is easy to get. This is max of cache values. So the values start the frequencies. So for the return, we just need to use a list comprehension. So the key for this dictionary cache is the tree sum, and the value is the corresponding frequency. Then we are going to for S and frequency in cache items if frequency equals the max frequency, right? Then this actually forms the full solution. So now I guess we are ready to do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. I guess for this problem, that's about it. Actually here, what we are using is a continuous update. We're using cache. We write a hyperfunction to do the update, and then we do function call and prepare the return. So the problem logic here actually is relatively simple. So, but do the implementation and in an effective way is also a consideration. With that said, I guess that's it for this video. Thank you.